Alright, I'm going to do a quick overview of 5.5. Your assignment for the lesson is page 444, 3 through 60 multiples of 3. It's only 20 problems. Shouldn't be too difficult to get done if you'll just work on it. So I encourage you to make sure you get all of 5.5 done. That's one bonus point that'll help you significantly. Plus, if you haven't practiced this before the test, it becomes pretty difficult to do. So what I thought I'd do is I'd just do a few random problems similar to 3 through 60. So, multiples of 3. So I'll do, let's start with number 2. Problem 2 is 2 to the x equals 32. Well, they become pretty easy to solve if you can write 32 as a power of 2, which I can. 32 is 2 to the 5th. And you can kind of check that. Okay, do 2 to the first, 2 to the second. If there's not a power of 2 that's equal to 32, then you're going to have to do a different approach. But if 32 is 2 to the 5th, that means x would have to be 5 because these exponents have to match. Problem 4. 3 to the 7x equals 27. Well, again, 27 can be written as a power of 3. It's 3 cubed. So now the bases match. What we need is we need for the exponents to match. So 7x has to equal 3. So x is 3/7. Pretty easy with that one. I don't know why that's not canceling out. 3/7. Maybe problem number 5. Now this one, 2 to the x equals 33. Well, you should know that 33 is not a power of 2, but if you don't know it, you could try. 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, so it's somewhere between 5 and 6. I just don't know where it is. So if I can't find it as a power of 2, what I'm going to do is I'm going to log both sides. As long as I do the same thing to both sides, I am in good shape. So log of 2 to the x will equal to the log of 33. Bring this x that's the exponent, use your power rule, bring it to the front. So it becomes x log of 2 equals log of 33. So then to solve for x, all I have to do is divide by the log of 2. Be careful when you do this on your calculator. Make sure you're using your parentheses like you should. So x will equal, it's going to be the log of 33 divided by the log of 2. Log of 33, close my parentheses, divided by the log of 2. And my answer for x is going to be 5.044. Where they say round, they didn't tell me where to round to. So 5.0444. If I round correctly, 5.0444. And you may round to fewer decimal places unless it specifies what you have to do. Alright, so let's look at some more. I'm going to do this for about 10 minutes. We'll see how far we get. Let's try problem number 8. Problem 8 is 4 to the 3x minus 5 equals 16. So in this particular one, I can rewrite 16 as 4 squared. So now I'm just dealing with exponents again. 3x minus 5 has to equal 2. Add 5. Again, divide by 3, and I get 7/3. Number 10 is a little bit more difficult. Number 10, in fact, I'm going to stop and I'm going to look at number 9. I'm not going to solve it because I know it's one of your homework problems, but it looks different than the other ones. 27 equals 3 to the 5x times 9 to the x squared. And it looks different, but I think it may look a lot like one of your problems on your review. I'm looking for powers of 3 because I've got 3 and I've got 9 and I've got 27. They can all be written as powers of 3. So rewrite 27 as 3 cubed. This one's already written as a power of 3. And 9 can be written as, whoops, that should be a times, not an equals, 3 squared. And then I still have an x squared up here. So it's 2x squared instead of just an x squared when I change 9 to 3 squared. So the left side is going to become 3 cubed. And the right side, when you're multiplying powers of like bases, you just add up the exponents. So basically, I need 3 to equal 5x plus 2x squared. And you're going to solve that as a quadratic. I'm going to stop here because you can solve it from there. I'm trying to think. It looks like it can be factored. So you're just going to you can factor it or you can use quadratic formula. Verify that the answers you get really work. We'll look at number 10. It is quadratic as well. And I will do it all the way. Problem number 10. 3. Whoops, I didn't give myself a new screen. I thought I did. Number 10. 3 to the x squared plus 4x equals 1 over 27. Well, that x should be up here. I can write 1 over 27 as a factor of 3. It's actually 3 to the negative 3 power. 3 cubed is 27, so since I want 1/27th, it's negative 3. You can check it out in your calculator and make sure. Now the bases match, so I need the exponents to match. So I get x squared plus 4x equals negative 3. It's quadratic, so I'm going to add 3, set it equal to 0. This can factor. It's where all that work on polynomial functions comes into play, and quadratic functions. So x plus 3, x plus 1. So when I solve it, I get x is negative 3 and x is negative 1. I'm not sure that they will both work, so I want to check it. I'm going to go ahead and type this in my calculator. In y1, I'm going to put 3 to the x squared plus 4x. And in y2, I'm going to put 1 over 27. Now I want to make sure that these are going to match at negative 3 and at negative 1. We'll go to the table. And at negative 3, I get the same answer. And at negative 1, I get the same answer. So those two both will work. Sometimes only one will work because of the nature of exponential functions. All right, so let's skip on down. So we got some that have bases that don't match, like number 11. 84 to the x equals 70. So when the bases don't match, the easiest thing to do is log both sides. Log of 84 to the x equals log of 70. Bring this exponent to the front. X log of 84 equals log of 70, and then just divide. Remember when you divide to use your parentheses. So it would be log of 70 divided by log of 84. Clear, go to a regular screen. Log of 70 divided by log of 84. And 0.9589 would be my answer. Alright, then you get to some that have e's, which means we're going to use natural logs. So, for instance, problem number 16. E to the 4t equals 200. So, to cancel out an e, I'm going to need to do a natural log on both sides. So, just rewrite the problem, but put a natural log on both sides. Bring this to the front. So, 4t times the natural log of e equals the natural log of 200. Natural log of e is 1, so I get 4t equals the natural log of 200. And to solve for t, I just divide by 4. So the natural log of 200 divided by 4. Make sure you close your parentheses again. Natural log of 200, close my parentheses, divided by 4. And my answer is 1.3246. T equals 1.3246. Let's skip on down. Most of these, so then we get to some that are written not in exponential form, but written in logarithmic form, like 29. Log base 5 of x equals 4. So rewrite it as exponential. 5 to the 4th equals x. Real easy. 5 to the 4th is 625, so x is 625. Sometimes you'll have them like 31, where it's just log of x equals a number. The base is not written. This base is 10. They don't have to write that. So if you rewrote it to be 10 to the negative 4th equals x, and 10 to the negative 4th is 1, 2, 3, 4, 1 over 10,000. Because that negative exponent just means it'd be in the denominator, 10 to the 4th. I could have a problem like 35, where I have log base 2 of 10 plus 3x is equal to 5. So when I rewrite that, it becomes 2 to the 5th equals 10 plus 3x. Remember, 2 to the 5th equals 10 plus 3x. So 2 to the 5th is 32. Subtract 10 and divide by 3. So x is 22/3. Do make sure that your answers all work. Sometimes in problems like 38, you've got two logs that you've got to put together first before you can rewrite it. X minus 1 equals 3. So before, I needed a single logarithm before I rewrite it as exponential. So since this is a sum, I could put it together as a product if I want to combine them. Now we did that back in an earlier section using our property. So this would be Now that I have it as a single logarithm, 2 cubed equals x plus 1 times x minus 1, which would be 8 equals x squared minus 1. Or subtract 8, I get x squared minus 9. So if I factor this, x minus 3 and x plus 3, I'd get x equals 3 and negative 3. But here's a problem. 3 is going to work because if I put 3 in, this would make this a 4 and it make this a 2, which will work. But if I plug in negative 3, I'm taking the log of a negative number, which I can't do. And you can try it on the calculator, but the only one that's going to work for this particular problem is going to be 3. All right, I'm at 10 minutes, so I am going to leave it there with you guys. And if you have any questions, please email me or respond on Selly.